Hey everyone, welcome back for another deep dive into the world of AI and all things fascinating.
I'm excited to be here.
Me too. Our listeners always send us the most interesting stuff, and this time is no exception. We've got a research paper titled uh, Demystifying Long Chain of Thought Reasoning in LLMs. And, well, it's a bit of a mouthful, but it's got some seriously cool ideas that I can't wait to dig into.
Yeah, LLMs, large language models, are already making waves, but what's got people buzzing is their potential to go beyond just generating text and actually reason through problems in a way that we used to think was uniquely human.
Exactly, and that's where this idea of chain of thought prompting, or CODI, comes in.
Right, Kuti is basically about guiding the LLM to think step by step, like how we might solve a math problem or plan a project.
It's like giving it a set of instructions or prompts to follow. So instead of just spitting out an answer, it actually shows its work, so to speak.
Yeah. Exactly. And the paper we're looking at today takes this concept even further. It explores something called long COTEs, which are essentially extended reasoning processes that can involve things like backtracking error correction and even branching out to explore multiple solutions simultaneously.
Well, hold on a second. You're telling me that these LLMs are being trained to not just follow a simple set of steps, but to actually think, critically evaluate their own progress, and adjust their approach as needed? That sounds incredibly sophisticated.
It is. And that's what makes this research so groundbreaking. It's pushing the boundaries of what we thought was possible with AI. It's no longer just about pattern recognition. It's about genuine problem solving and reasoning.
My mind is officially blown. So how exactly did the researchers train these LLMs to become such impressive thinkers? What kind of wizardry is involved here?
Well, one of the key techniques they used is something called supervised fine-tuning, or SFT. Think of it like giving the LM a crash course in reasoning.
A crash course. So they're essentially feeding it tons of examples of how to reason through different types of problems.
Precisely. But here's the really interesting part. The researchers found that training on long-cut examples, those with more elaborate reasoning steps, actually led to far better results than using short, simple ones.
Now that's counterintuitive. Wouldn't you think that simpler examples would make it easier for the LLM to learn?
It might seem that way, but it turns out that exposing the LLM to those more complex reasoning patterns actually helps it develop a deeper understanding of the underlying principles. It's like if you only ever practice basic math problems, you'll never develop the skills needed to tackle advanced calculus.
That makes a lot of sense. So by giving the LLM a taste of the hard stuff, it actually learns to reason better overall. It's like they say, what doesn't kill you makes you stronger.
Exactly. And the results speak for themselves. When they tested these SFT-trained models on a benchmark called Math 500, the long-cut models achieved over 70% accuracy,
Wow, that's impressive.
while those trained on short-cut Ts barely reached 55%.
That's a huge difference. So longer Cox equals a stronger foundation in reasoning.
Absolutely. It seems so. But I'm guessing they didn't stop there, right? Supervised fine-tuning is just the first step. There must be more to the story than just initial training.
You're right. Supervised fine-tuning is just the foundation. They then turn to something called reinforcement learning, or RL, to further refine those reasoning abilities, to kind of take it to the next level.
Exactly. Think of it like this. If SFT is like giving the LLM a textbook, RL is like having a tutor who guides you, provides feedback along the way.
So instead of just passively absorbing information, the LLM is now actively interacting with its environment and learning from its mistakes.
That's the idea. But here's where things get a bit tricky. RL relies on what's called a reward signal to help the LLM learn. This signal needs to be something verifiable, like whether it got a math problem right or wrong, so the model knows what good looks like so it can improve.
It's like giving it a pat on the back when it does something right, or a little nudge in the right direction when it goes astray. But I bet figuring out how to provide that feedback effectively is easier said than done right.
You got it. Simply scaling up RL or giving it more feedback doesn't always guarantee better or longer COTEs. Sometimes it leads to instability or even worse performance. Imagine encouraging a student to spend more time on a difficult problem, but they keep repeating the same wrong steps. Not very helpful, is it?
That makes sense. So it's not just about thinking more, it's about thinking in a way that actually leads to the right answers.
Yeah.
So how did the researchers tackle this challenge? Did they find a way to ensure that more feedback actually translated into better reasoning?
They did. They came up with something called the cosine reward function. And what's fascinating about this function is that it actually uses COTE length as an input, encouraging the LLM to explore those longer, more complex reasoning paths without getting stuck in a rut.
So it's like the reward function saying, hey, don't just keep repeating the same steps. Try something new. Explore different approaches. even if it takes a bit longer.
Exactly. And by carefully tuning the parameters of this cosine reward function, the researchers could influence how the LLM approaches a problem, making it more likely to delve into those deeper chains of thought, like a conductor guiding an orchestra to create a more complex symphony.
I love that analogy.
Yeah,
It really highlights the delicate balance between encouraging exploration and ensuring that it leads to meaningful results.
that's good.
Well, let's step back for a moment. We've talked about training and reward functions, but these models must need a ton of data to learn effectively, right?
Absolutely. You can't teach an LLM to reason without giving it something to reason about, and that's where the importance of data comes in.
So what kind of data are we talking about here? Are we talking about textbooks, scientific papers, or something else entirely?
Well, the researchers highlighted the need for vast amounts of verifiable data to train these LLMs. And not just any data. It needs to be data where you can actually check if the reasoning is correct, like in those math problems we talked about
It's
earlier.
like the old saying, garbage in, garbage out. If you train an LLM on bad data, you're not going to get very good results.
Exactly. But this is where things get tricky. Relying solely on carefully curated human-annotated data just doesn't scale. There simply isn't enough of it out there to train these increasingly complex LLMs. It's like trying to build a skyscraper with just a handful of bricks.
So if human annotated data is too limited,
Huh.
what other options did the researchers explore? Did they find a way to break free from this data constraint?
Well, they turn to what they call silver data. Think of it like a compromise between quality and quantity.
Silver data. So it's not as perfect as that human annotated stuff, but it's more readily available.
You got it. One data set they looked at is WebInstruct. It's a bunch of question-answer pairs pulled straight from the web.
The web, isn't that a recipe for disaster? I mean, the internet's full of misinformation and opinions and who knows what else.
True, but surprisingly, it worked. Combining this silver data with the good old human-labeled stuff actually boosted performance on a wider range of tasks.
So it's like cross-training for LLMs. Exposing them to a wider range of information makes them more adaptable and well-rounded learners.
Exactly. It's not just quantity, but diversity, like a balanced diet for the AI mind.
Love that. I got to ask about something for the paper. It mentioned an aha moment in a previous study where long Coney kind of just appeared out of nowhere. What was that all about?
Ah, yeah, that was a wild one. They found that just scaling up RL on a basic LLM could lead to spontaneous long-coded reasoning. No special training or prompts, just pure reinforcement learning magic.
So the LLM suddenly figured out how to do these complex chains of thought all on its own, like it had a sudden epiphany.
It seemed that way. But these researchers tried to recreate it with a model called Quen 2.5 Math 7B, and while it didn't quite go as planned,
No aha moment round two.
not exactly. RL did improve performance, but it didn't really lead to those fancy long cootie hallmarks like self-correction. Made us wonder if those abilities were already there lurking beneath the surface.
Like hidden talents just waiting to be unlocked. Intriguing.
Right. They even found hints of long coatee-like patterns in online discussion forums, the kind of stuff LLMs are often trained on.
Hold on. You mean all those online debates and arguments the LLM might be learning to reason from that? That's both amazing and kind of terrifying.
It is. It shows how much human communication is shaping AI development. But it also raises questions. What if they pick up bad habits too? Biases, logical fallacies.
Yeah, that's a whole other can of worms.
Yeah,
So how do we make sure they're learning the right things from us?
that's the million-dollar question. Researchers are working on curating training data that emphasizes fairness, accuracy, and ethical reasoning, like building a moral compass for the AI.
So it's not just about feeding them any information. It's about choosing the right information that aligns with our values.
Absolutely. And the structure of that information matters too. Remember those long Cody examples? That structure provides a framework for the LLM to learn robust and reliable reasoning skills.
It's like giving them a blueprint for thinking clearly and logically.
Exactly. As we refine these training methods and data curation techniques, we can nudge LLMs toward more ethical and nuanced forms of reasoning.
Yeah. Okay, that's reassuring. But let's be real. These LLMs are massive. Training them must take a ridiculous amount of computing power.
You're not wrong. The bigger the model, the more data it needs, the more compute power you got to throw at it. It's a real bottleneck.
So we need bigger and better models to unlock even greater reasoning abilities. But the training itself is holding us back.
Yep. Even with the best hardware and software, scaling up to billions or trillions of parameters is a monumental task.
It's like trying to build a rocket ship with a screwdriver.
Whoa.
We need better tools to push the boundaries.
And that's where the field of machine learning systems research comes in, developing new algorithms, hardware architectures, software frameworks to make LLM training more efficient and scalable. It's a whole ecosystem evolving around these LLMs.
So we've got the data, the models, the training, the hardware. It's a massive undertaking.
It is. And it's just the beginning. There's still so much we don't know about how these LLMs work. The paper even mentions the difficulty of actually measuring the emergence of long code T. How can we be sure they're using complex reasoning and not just mimicking it?
Right? It's like trying to read an AI's mind. We see what they do, but we don't fully understand how they think.
Exactly. Transparency and interpretability are becoming crucial. We need to understand how they make decisions, not just what decisions they make.
So building a powerful LLM isn't enough. We need to understand how it reasons and ensure that reasoning aligns with our values and goals.
Precisely. It's a responsibility we all share. Researchers, developers, policymakers, even users like you and me. We need an open dialogue about this technology and work together to make sure it's used for good.
That's a powerful message and a great segue into the final part of our deep dive. Stay tuned, folks. We've got more to unpack. All right, we're back for the final leg of our journey into long-cost Ts and the amazing reasoning abilities of LLMs. We've talked about training data reward functions, even the philosophical implications of AI learning to think like us. But before we wrap up, what's the one big takeaway you want our listeners to ponder?
I think the most important thing to remember is that we're witnessing a monumental shift in AI LMs, are showing us that reasoning isn't just something humans do. It's a capability that can emerge in different forms and that has profound implications for how we understand intelligence itself.
It really makes you wonder, if these LLMs can reflect human thought processes back at us, does that mean we're not so unique after all? Is intelligence a spectrum rather than a binary thing?
It's a fascinating question. Maybe both humans and machines are on this journey of intelligence, each learning from the other, pushing the boundaries of what's possible.
It's a humbling thought to consider that we might not be the only ones capable of complex reasoning, that there might be other forms of intelligence out there waiting to be discovered.
And imagine the possibilities for collaboration. Humans and LLMs working together, leveraging each other's strengths to solve problems that have stumped us for centuries. It's a future full of potential, but also uncertainty.
It's like we're stepping into a whole new era of problem solving, one where the lines between human and machine intelligence are becoming increasingly blurred. And this research into long queues is giving us a glimpse of what that future might hold.
But it's important to remember that this technology is still in its early stages. There are challenges to overcome, ethical considerations to address. We need to be thoughtful about how we develop and deploy these LLMs, ensuring they're used for good.
Absolutely. We have a responsibility to guide this technology wisely, to ensure it benefits humanity as a whole. And that starts with understanding how these LLMs work, how they reason, and how we can shape their development through careful training and data curation.
It all comes back to curiosity. The more we ask questions, explore, and learn, the better equipped we'll be to navigate this exciting but uncharted territory. The future of intelligence is in our hands. Let's make it a future worth creating.
That's a great message to end on. This has been an incredible deep dive into the world of long queues and LLMs. I hope you've enjoyed the journey as much as we have.
It's been a pleasure sharing these insights. And to our listeners out there, thank you for joining us. Keep those questions coming, keep exploring, and never stop being amazed by the power of human and artificial intelligence.
This is The Deep Dive signing off.